Gideon. Hopefully this will help you understand radicals. These are example problems similar to your assessment at the end of Unit 5, Lesson 1. So when simplifying this particular number, remember we have to find perfect square, the largest one, that will go into 96. So I'm thinking, I know that the perfect squares are like 4, 9, 16, 25, 36, so on and so forth. Well, I know after over 36 I'm getting too big. So I might see if 36 would go into 96 evenly, and I can see that it doesn't. It gives me like 2.6 something. So the next number I would try to see is 96 divided by 16, because that's a perfect square. So I can see that 6 times 16, 16 times 6 gives me the 96 I'm looking for. I did that so I can get rid of a perfect square, because I know the square root of 16 is 4. And then I bring down my 6. So 4 radical 6 is the simplified form of radical 96. If I'm writing this, and this is the 44a to the 11th power, I want you to remember that there is a 2 here if we don't see it on the square root. So I'll get back to that in a minute, but let's look at the 44 first. So I know that I can take 4, which is a perfect square, times 11. So I know that the square root of 4 is a 2, and I've got radical 11. But now I'm going to take a look at that a to the 11th. What I really want to do is put the 11 and divide it by the 2. I'm going to take it and divide it by the radical symbol. So how many times will 2 go into 11 evenly? And I'm going to write it over here. And I know that 2 goes into 11 5 times evenly. How many are left over? 1. So the 1 is going to stay inside. And really, I don't need that 1 there. So I'm going to add this to my answer. So I've got 2, a to the 5th, radical 11a is my final answer. So when doing like the square root, say this is 7, remember you're taking the exponent and you're really dividing it by the 2. So how many times will x go into 7 evenly? That's 3. That comes outside of the radical sign, and then the remainder stays inside. So x cubed radical x. Hopefully that makes sense. If not, give me a text or webmail, and I'll give you more information. All right, so moving along to simplifying this. We can only do outside numbers. And remember, if we don't see one, it's the number 1 there. I'm not talking about in the radical symbol. I'm just talking about the whole number outside. So 2 times 1 is 2. Now, I can multiply inside the radical. I don't have to have the same values if I'm multiplying. So 3 times 20 is 60. That was a bad 60. Remember the exponent rules. You're multiplying the same base, so you add exponents. So this is a to the 6th. So I need to continue to simplify it. So I'm going to continue to simplify it first by doing my 60. So I'll find a square root that will go into 60 evenly. And if I think 4. 4 goes into 60 15 times. So I did this so I can get my square root of 4, which is 2. I already have an outside number, so I'm going to multiply those two numbers together. So 2 times 2 is 4. Okay. Hopefully you're staying with me. And inside the radical, I have a 15. So now I'm going to take the next element of a to the 6th. And remember, we're dividing it by the square root. The square root number is 2. So how many times will 2 go into 6 evenly? And it's 3 with none left over. So a3 goes outside the box, and there's not a variable inside the box. So that is your simplified form. Hopefully this will help you on your test. Okay, then there's another way of doing it. This is just asking you. You're supposed to identify. You're not really writing it. You're identifying the simplified form. What is in the simplest form? So remember, there's going to be no radical sign in the denominator. So let's look at our examples. So I'm looking at 2a over radical 2. Well, this can't be, so this is not simplified. The second choice, I don't have any radicals in the denominator. It's okay to have a variable, so this could be it. This one is not simplified because this is the square root of 9 is really 3. And the same thing for the last one. Remember, we could break those down like this. So really this is 6 over 7. So the answer here would be radical 7 over 7y. So the radical can be on top in the numerator, but not in the denominator. And then finally, for number 5, I wanted to remind you of how to solve this. You've got something similar. Again, my numbers are different, about a gardener mowing a lawn. And, you need to find the diagonal. And remember, the diagonal, because it's a rectangle, I've got a right triangle, so I'm going to use the Pythagorean theorem, and I'm going to remember that always across from the right angle is my C, or my hypotenuse. And so I use that so I can have A and B and then C. A squared plus B squared equals C squared. So let's use our numbers. 50 squared plus 30 squared equals, I don't know what C squared is. So I need to know what 50 squared is. And I know 50 squared comes to 2,500. And then I'm going to do my 30 squared, which comes to 900. That's going to equal C squared. Add 900 and 2,500, and we get 3,400, and that equals C squared. Now remember, we're taking the square roots. To get rid of the radical, we have to take the square root. So what we do to one side, we do to the other. So now I need to see if there's any number that will go, perfect square, that will go into 34 evenly. So first I'm going to see if I can take the radical 3,400. It's not going to be an even number. So I'm going to try finding a perfect square that will go into it. And I may start small and work my way up. So I know 4 goes into it, but I think there's going to be probably a bigger one. I'm going to try 25. That works. I'm just going to try that one first. So over here, I'm going to do the 3,400, the radical. This could be square root of 25, and then I'm left with 136. These two multiplied together give me 3,400. So now I've got 5 radical 136. I'm going to look at the 136 and see if there's anything else I can divide a perfect square by. So I may start with, I know 81 is too big, so I may start with 64. 7 is 49. I'm going to work backwards in my mind to see if I can find one that goes into this evenly. 25 won't work. 16 doesn't work. 9 doesn't work. 4 works. So this is really radical 4 times 34, radical 34. That gives me my 136. Remember, we did this to get the radical 4s too. I have 2 outside numbers now, so I multiply those together, giving me 10, and then the square root of 34. And I know that the square root of 34, there's not a perfect square that goes into that. So, the 4 doesn't go into it, 9 doesn't go into it, etc. So your final answer is 10 radical 34. Hope this helps.